Hello, this is Space News with Julia. The James Webb Space Telescope has finally reached its orbit and is preparing for its first scientific investigations, the result of which we eagerly await. But it took scientists several years of research and development to be able to use this precision space instrument today. And it took a total of 24 years from the time the plans for the new telescope were made until its launch. And because the development of space observatories take many years, scientists are already working on a new space telescope, which will replace James Webb, a large UV Optical Infrared Surveyor (LUVOIR), which is planned to be launched in 2035. Unlike Webb, this telescope will operate in the ultraviolet, optical and infrared ranges. Now the agency NASA has two telescope projects, LUVOIR-A with a 50-meter mirror and LUVOIR-B with 8-meter primary mirror. But only one of these projects will be realized. The primary mirror of LUVOIR Space Telescope, as at James Webb, will be folding. It's assumed that the telescope with a 50-meter mirror will be able to launch with NASA-developed rocket space launch system, and the telescope with an 8-meter mirror will be able to launch with European Space Agency's Ariane 5 rocket. The observatory will work the same way as James Webb at the second Lagrange point of the Earth-Sun system at a distance of 1.5 million kilometers from Earth. The LUVOIR Large Telescope will be equipped with 4 scientific instruments in configuration A, or 3 instruments in configuration B. Among the instruments will be a coronagraph designed to suppress starlight so that planets can be seen close to their parent stars, an instrument for near-ultraviolet and near-infrared observations, a multi-object spectrograph capable of observing hundreds of objects simultaneously in a wide field of view, and an ultraviolet spectropolarimeter to measure the magnetic fields of a wide range of objects. One of LUVOIR's main scientific goals will be to detect and characterize exoplanets around nearby stars, including determine the chemical composition of their atmospheres and surface conditions. Currently, astronomers can detect exoplanets, but cannot determine what they are. Is this planet rocky and lifeless? Or does it have oceans and possibly life? The James Webb Telescope, which has a mirror diameter of 6.5 meters, may be able to shed some light on this question. However, a telescope with a 50-meter mirror will be able to collect several times more light than the James Webb Telescope, and therefore will be able to study a much larger number of exoplanets and examine more distant planets. To discover habitable conditions for life outside our solar system, we need to explore as many worlds as possible, which is only possible with a large telescope. Space Daily News, stay tuned with us and don't forget to subscribe.